Hi guys, this is lesson 2-3, solving multi-step equations. And I'm going to be in the textbook. The lesson starts on page 91. I'm actually going to be on page 94 because I think the best way to talk about solving multi-step equations is going to be just to tackle some problems. I'm going to tackle some problems in the book. Feel free to pause the video so you can work them yourself and then start the video back up and see how you did, or if maybe I can answer some questions. And then when you're done with this, you can go on to do the exercises in ALEX. I'm going to start with number 11. Which says 3t plus 7 equals -8. I have a funny way of explaining how to choose what step to start with M&Ms, but it tends to make the video long if I chatter on. So I'm going to save that maybe for a different demonstration. In this case, what I'm going to just tell you is that we're going to look at an equation, decide where the variable is that we want to get all by itself, because that's actually going to tell us the answer, and work further away from the variable. So let's get the things that are kind of out on the edges first. It's also the same as doing reverse order of operations. So instead of doing parentheses and then exponents, multiplication and division, and then addition and subtraction, you actually want to start with the bottom of that. You want to start with addition and subtraction, then do your multiplication and division. But one way to just kind of mentally see it or visually see it is that you're going to work further away from the variable. So in this case, I'm going to tackle this plus 7 first. I'm going to use the subtraction property of equality because -7 and +7 cancel each other out. I would then be just adding 0 to the equation, and anything added to 0 or 0 added to anything is just what it is. And I would have 3t on this side. However, I have done something completely illegal right now. My equation is very imbalanced. I took away 7 from the left. So I need to go do that to the right to keep it balanced. -8 and -7 together make -15. And then I'm looking at 3 times t. 3 times t can be undone by dividing. And so I'm going to use the division property of equality. 3 divided by 3 just becomes 1, and 1 times t, that's the identity property of multiplication. 1 times anything is itself. So we'll just have a t on this side. And also, to keep things very balanced, I'm going to need to do that same division on the right-hand side. -15 divided by 3 is -5, and I am done with my problem. All right, number 12. 8 equals 16 plus 8n. Again, when we look at this equation, I want to look farther away from the variable n and take care of the 16 that's out here as that's called a constant, a number that doesn't have a variable. So since it's a positive 16, I'm going to subtract 16 to cancel that out, and I have to do that on both sides. So 8 and -16 gives me -8 equals, this canceled, became a 0, so 8n plus 0 is just 8n. And then I need to deal with this 8 times n. I can undo this multiplication by dividing. Because remember, adding and subtracting cancel each other out. Multiplying and dividing cancel each other out. I have to divide by 8 over here. I like to show divide by a line. If fractions are involved, it often makes giving the answer really easy. Hopefully we'll see a problem like that. -8 divided by 8 is -1 on the left, and on the right we have canceled out and made a 1, and that's just n. I like to sometimes flip these around. N equals -1. Just sounds like a good way of saying what I have discovered there. All right, let's jump down to some problems that look a little less friendly. Let's do number 15. And again, stop the video, work it for yourself. Okay, same thing. I want to work further away from my y, and so I'm looking at this -6 here, and -6 can be canceled with a +6. I'll do that on both sides. And so I'll end up with y over 5 equals 14. So I need to deal with this y divided by 5. And the thing that will undo division is multiplication. So we're going to multiply by 5 on the top, 5 over 1 if you want, because that'll cancel 5s. 5 over 5, this would become 5y over 5. 5 over 5 is just 1. So we've done all that to get y by itself. I'm going to come over here, and I'm going to multiply by 5 over here as well. Doesn't really matter if I write 5 over 1, it's the same number. Y equals 14 times 5 is 50 and 20, which is 70. Let's go down to number 19. N minus 2 over 7 equals 2. All right, so in this case, I want to deal with not that -2, even though I told you we're going to want to do the addition and subtraction first, but it's messy because the divided by 7 goes under the whole thing. So I actually have n over 7 minus 2 over 7, and then I have to deal with all those fractions. So it's actually totally fine to think about this being in parentheses. And we can then multiply by 7. This is actually, maybe you could think of 7 over 1 if you want, because I want to cancel those 7, so I want to get rid of that 7. So we're going to multiply by 7 over here, and then notice what happens. I just have n minus 2. That's what was in the parentheses that I was thinking about. And fractions really make parentheses. What's on the top is in parentheses, and what's on the bottom is in parentheses. So you can really think about that. N minus 2 like that, and actually everything on the bottom is separately in parentheses. Okay, n minus 2 equals 14, and then I'm ready to deal with this -2. Plus 2 will cancel out that, and I'll have n, so I've got to do plus 2 over here, and so n equals 16. And I'm not seeing your work right now as much, but I would really encourage you to write these steps down while you're practicing and getting good at this. Let's see. Let's do number 21. It looks complicated. -11 equals a minus 5 over 6. And if you want to work any more of these problems, just ask me and I will just take a picture of the answers and send it to you, so you can grade it for yourself. I want to deal with the 6 on the bottom here. So let's times by 6 because that'll cancel. Yep. And I'm going to times by 6 over here. So this is -66 equals a minus 5. All the parentheses I'm putting on are just for my own thinking. They're not really changing what I do. And a minus 5, I want to get rid of this -5, so I'm going to plus 5. -66 and 5 is going to give me -61 equals a, or we could then say a equals -61. All right, let's see. Okay, let's look at something like number 36. There's enough fractions to send you running if you're afraid of fractions. negative 5 halves equals 3/4 z plus 1/2. Okay, you can deal with these just the same as regular numbers. Subtract 1/2 from the other side. In fact, maybe I'll just show you that really quick. I'll just show you if I did nothing else with the fractions, this is what it might look like. This would become negative 6 halves and equals 3/4 z. And then getting rid of 3/4, I can multiply by 4/3. See, 4's cancel and 3's cancel. So whenever you have a fraction, multiply by the reciprocal of that fraction and it'll cancel itself out. Do exactly the same thing on the other side. And we end up with, I could do some canceling, but I'm just going to multiply the tops and multiply the bottoms and then go ahead and simplify it. Negative 24 divided by 6 is negative 4, or we could say z equals negative 4. Okay, another way of doing that one, you might like this and you might not like this. It's a pretty good technique later on. Let's say I'm looking at the same problem. Yep. Negative 5 halves equals 3/4 z plus 1/2. And a common denominator to all these fractions would be 4. So I'm just going to multiply everything by 4. 4 times negative 5 halves becomes negative 10. Try it in your calculator if you don't believe me. 4 times 3/4 z just becomes 3z plus, and 4 times 1/2 becomes 2. And now I have a problem that is equivalent to my original one, but has no more fractions. So if I finish this out, I'm going to subtract 2. Gives me negative 12 equals 3z. Divide by 3. And I have negative 4 equals z, or z equals negative 4.